Hello, this is Dad and welcome to another MAT video. Today we're now going to do question 5 of 2018. Great, so here's a 4 tower. Draw the other 4 towers. This should be easy. So what we need is a 4 brick here. So the above tower, I'm going to be writing it as like this: 1, 1, 2, 1, 3, 1, 4. So this is how I'm gonna write it. So here are the 4 other 4 towers. So let's include the one we already written down in here. So that means there will be 4 towers. So 1, 4, 1, 3, 1, 2, 1, 1. So I'll have 1, 4, 3, 2, 1, 1, 1. This is the one we already written down. So we're gonna cancel it out. And so 4 is also 2 plus 2. And we're gonna write 1s each here. So 4, 3, 2, 1, 1, 1, 1. And then we also have 4, 3, 1, the mirror image of what we had. There, got that. So what is the maximum height of an N tower? It's N. Because, as you can see, 4 of these towers have a height 4. And that is the maximum height. And besides, it can be explained by having a 4 brick here. Let's say you have a big N brick here. Let's use this pen as our metaphor for an N brick. Then you have an N minus 1 brick here, then N minus 2, and so continue on to 3, 2, 1. Sorry, you can't see my pen. It's just a metaphor. So what is the area of a tower is defined as the sum of the width of its bricks. Give an expression on the area of N tower maximum height. So it always ends at N1. So it's N times 1 plus 2 plus 3 plus dot 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 plus N. Great. So we're going to write it this way. And this is a very interesting formula. Actually, it's a very simple one. N plus 1 over 2. There, we got an expression. If you like, you can simplify it further, but for now, that's what I'm going to use. So, show that there are infinitely many n such that there's an n tower of height exactly 1 plus log 2n. As you can see, we have this tower here. Now, we are going to copy it here. And we're going to copy it to make an 8 tower. Yes, an 8 tower. So, we're going to draw a big 8 here. A big 8, and here's our 8 tower. And so therefore there is infinitely many n such that n tower height exactly 1 plus log 2n. They are the powers of 2 because you can't have half of a brick at the top. So write Tn for the number of n towers. We have T1 is 1. For n is greater than or equal to 2, make a formula for Tn in terms of Tk for k is less than n. Tn equals to Tn minus k equals to 1 to n minus 1. This is easy to show because you can have 4 is 1 plus 3, 4 is 2 plus 2, 4 is 3 plus 1, and etc. So what are these towers? Let's stop for a moment and think about them. They have such a very elegant formula for them. So they must be some important mathematical objects. Usually simple, but important mathematical objects usually have these formulae. It turns out these are binary trees. It turns out these n towers are actually mathematical objects known as binary trees, in which you can have only 2 edges stem out from each node. So now we're asking on the number of binary trees or towers, as what the MAT calls them, for each of them. So T4 is 5. So T1 is 1. T2 is 1. T3 equals to 2, as we've seen. T4 equals to 5. T5 equals to 1 times 5 plus 1 times 2 plus 2 times 1 plus 5 times 1 equals to 14. So I'll spare you the gory details, which is a phrase I like to say, but it will make T6 become the answer to life, the universe, and everything for T2. Very, very interesting. Show that Tn is odd if and only if T2n is odd. Well, basically, if Tn is odd, as you can see, this alternates between odd, even, and then etc, etc. And realize that if Tn is odd, let's say Tn is odd, T1 is odd, T2 is odd, T2 is 1, T4 is 5, T3 is 2, T6 equals to 42, and so we have some special cases. But how do we make a special proof out of this? So if Tn is odd, sorry I'm beating around the bush, we can use this formula to realize that. Okay, so we're gonna write our formula down by substituting n for 2n. T2n equals to tk T2n minus k. And so we can write it as this. So k equals to 1, 2n minus 1 equals to 2 times T1 T2n minus 1 plus dot 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 dot. Let's ignore this big one now. Plus Tn Tn. As you can see, this bit here is twice something. So that's even. And if Tn is odd, this odd number squared is an odd number. So this, if Tn is odd, Tn squared is odd. So 2 times any number is an even number. So an even number plus an odd number is an odd number. Yay, we proved it. So anyway, just reminding you, these are actually called binary trees. You can look it up on the internet, but usually the binary trees usually have some nodes dangling from them which only have one edge added to it, so you should be specific about what kind of binary trees. And if you like, you can actually enumerate these values and probably make a table of them. See you!